Here's question number 3 from the actual AP exam that was done in 2016. This is the real one. And so let's look at it together and see if we can answer it. So you're given the graph of f, and it's a piecewise where it's all linear. So you see these line segments here, they're all linear. And then this is the important part here. G at x is defined like this. So integrating from 2 to x, so if you integrate the graph, you'll get G. So we're going to just start with A and go from there and see what we're going to do. So the first question is for A, is does G have a minimum, a maximum, or neither at x equals 10? So how would you know if it has a minimum, maximum, or neither? So the derivative of G, I would have to see whether there's a sign change around it. So what I'd look for here is I would take the derivative and make it equal to 0, and then look at the signs that are around it to see if there's a sign change that would create what we're looking at. So first of all, if I take this, what G is defined by, and take the derivative of this, then you're doing the fundamental theorem of calculus. So the derivative and the integration undo each other. You just plug x in, and then the constant at the bottom would give you a 0. So for this answer, it's important to know the derivative of G is equal to f at x. So off the graph I'm looking for f at x equals 0 to begin with. So when I look at the function, it's not going to be a max or a minimum if f at x doesn't equal 0 there. So let's look at it again. So when x equals 10. So when x equals 10, is the function equal to 0? And the answer is yes. But that's not the only part. So the next part I look at is there a sign change there at 10? Meaning, does it go from negative to positive or positive to negative? And the answer is no. It's negative, and then it stays negative. And because there's no sign change, there's not a maximum, there's not a minimum, it's neither. So at x equals 10, G at x has neither, if I could spell that, a maximum or minimum. Why? Because and I would say it is decreasing around x equals 10. So there is no sign change. And you can write that down. It's okay to write that down as long as you're explaining it with words like increasing and decrease. So it's clear the person that's grading it knows why you said that there was no maximum or minimum. All right, 3b. Does the graph of G have a point of inflection at x equals 4? So G again, point of inflection. So for point of inflection, how would I normally find it? So it's the second derivative. So the second derivative equal to 0, and again I'd have to see a sign change for there to be a point of inflection. So we were already told what the first derivative is. The first derivative is f at x. So what do you think the second derivative then would be? And the second derivative is equal to the first derivative of f. So what I'm looking for, is there a point of inflection at x equals 4? So let's look at x equals 4. And I'm looking for a sign change. Now, when I'm looking at the derivative of f, what I'm looking for off the graph is I'm looking off the graph if it changes from increasing to decreasing at x equals 4. So let's look at x equals 4. Does f change from increasing to decreasing at that? And it could be either a maximum or minimum local value. And the answer is yes. It goes from increasing to decreasing at x equals 4. Therefore, at x equals 4, there is a point of inflection. Let's write it down. And then use the word because. So at x equals 4, there is a point of inflection because. And what were we looking at? The derivative of f changes from And I love these words again, increasing to decreasing at x equals 4. So you answer it correctly, a point of inflection, and you say why you chose that. And there's no perfect words for that as long as you explain it. I love the words increasing or decreasing, talking about calculus reasons. And that's it. Good job. 3B done. All right, 3C. And I'll do this on the back of the page. So 3C says find the absolute minimum and the absolute maximum value of G on that interval. So we're looking at G and looking for absolute minimum and absolute maximum on that interval. So what we're going to do is a table of values when we do absolute minimum or maximum. So I'm looking at G at x. I'm going to remind myself it goes from 2 to x, f at t dt. So I'm going to remind myself of that. And then I'm going to do a table of values. And what values will matter, and then I'm going to look at what values they give me. So the n values, first of all, matter. So the n's go from -4 to 12. So I need to look at the n values. And then I need to know, are there any parts where they're equal to 0 that I need to look at, where there's maybe a sign change and so on. So I'm looking at that, but I'm also taking the derivative and making it equal to 0. So that's also saying f at x when it's equal to 0. I'm looking off the graph. So let's look at there. So I'm looking at f when it's equal to 0. So first of all, I see it's equal to 0 at -2. I'm also seeing it changes direction there. So it goes from negative to positive. So that's one I need to look at. So that's what's called a critical number at -2. Then, is there another spot? Well, I see here it's 0, but why am I not going to write it down as a critical number? I'm considering it. Is because it's positive and then it stays positive. So it doesn't change direction there. It gives me a point I need to test. So I don't need to do that one. Why? Because it's positive and it stays positive. How about at 6? Does that qualify for me to change on my table of values? And the answer is yes, because it goes from positive to negative. So I'm going to put down 6. Are there any other values where it's 0? And the answer is at 10. But what do you notice about 10, and why am I not writing it down? It's because it's negative, or decrease, right? And it stays negative after 10. So that means I don't need to. So only when it changes direction is that critical number I'm going to write down. All right, so now I have my 4 values. I'm going to then plug into this to see what the answer is. So for -4, I want to evaluate from 2 to -4 the function, and then see what the answer is. From here, it's 2 to 12. This one here is 2 to -2. Could have made the chart a little bigger so I can fit these integrations. And then the last one's 2 to 6. Now, I'm going to draw a little line so I can make sure that I'm not running work into each other and frustrating me and not giving me a headache. So, in other words, I'm plugging each one of these x values into here and then using the graph to see what the value is. Now, for each of these, when I integrate off a graph, I'm finding the area under the curve and then figuring out what that area is. So, before I go any further, it's going to be helpful to know all the way across from -4 to 12 what the area is under. So the first part is from -4 to -2. It's a triangle underneath, so it's negative area. So what is the area of this triangle? Half the base times the height. So the base is 2, the height is 4, so half the base times the height. That's going to give you the answer of 4, but because it's below, it's going to be -4. All of these are triangles and easy triangles. Half the base times the height. That's 8, but because it's above, it's positive 8. Again, from 2 to 6, see the triangle. Half the base times the height. So again, the base is 4 and the height is 4, so half of that, that's 8. Again, we have another one, half the base. That's 4 again and 4, but this one's going to be a -8 because it's below. And then 12 to here, it's an awful vertical line, there you go. It's the same size as the one over here, half the base times the height, and it's below, and it's -4. Having those values then will make this easier to look at. So the first one I'm looking at is 2 to -4. So do you see 2 to -4? So that would be 8 and -4. So 8 and -4 together would make +4. But I'm going in a backwards direction. In other words, my greater number is on the bottom bound. and my lesser number's on the top. So instead of writing down positive 4, because the bounds are flipped, I write down the opposite sign number. So this one's actually going to be negative 4. And that's only because my greater bound is on the bottom. Whatever answer I get, I change the sign. None of the others, yeah, from 2 to negative 2, I'm going to do the same thing. From 2 to 12, it's written properly. Just whatever area I get is the answer. From 2 to 12. So from 2 to 12, I have 8 and negative 8. Well, they're done. They cross out, and so I'm just left with negative 4. So the beginning and the end give me the answer negative 4. How about at negative 2? That's bounded from 2 to negative 2. Notice again, the lower bound is greater. So whatever answer I get for area, I'm going to change the sign so I get right. From 2 to negative 2. So from 2 to negative 2, it would be 8. But because we're going backwards, we don't write down positive 8, but we write down negative 8. Now the last one goes from 2 to 6. This is going in the correct direction, where the lower bound is smaller. From 2 to 6, I write down what I see, and that answer is positive 8. Now I can look. Where does my absolute minimum occur? And so the absolute minimum is negative 8 when x equals negative 2. And the absolute maximum is positive 8 when x equals 6. So you found the absolute minimum and the absolute maximum, and you remembered to do the end values of the interval. You remembered what makes a critical number is when you have sign changes, when it's first of all equal to 0 and sign changes makes that critical value, and then know how it's defined, so when you plug in you can actually find the values you're looking for. And then all that hard work at the very end, which one is the biggest number, which one's the smallest number, and you have your answer. All right, last one. D. For negative 4 to 12, that means the whole thing, can you find all intervals in which g is less than 0? So we're going to remind ourselves again that this is how g at x is defined, the integration from 2 to x t dt. So it's good to know what value, first of all, it starts with. So we're looking for less than 0, which means like where it's negative value. So g starts off as a negative answer at negative 4. So let's start there. So it starts at negative 4, and then it keeps going lower to negative 8. So at negative 2, right now the value is negative 8. Then, even though it's above, it still stays negative all the way to 2. At 2, it's going to be 0, because we already have negative 8 plus 8. Well, that final 8 only happens at the very end at 2. That means from negative 4 to positive 2, it's negative all the way through. So we started at negative 4. Another negative 4 makes it negative 8. And then when we add 8, it's finally, the answer is 0 when we reach 2. So where is it negative to begin with? So first of all, on the interval from negative 4 to 2. Now, at negative 4, the answer is negative, but at 2, it's actually 0. But does it say when it's less than or equal to 0? It does, so it includes this one. So we're looking for when g at x is less than or equal to 0. So negative 4 is included and positive 2 is included. We could also write it this way, from negative 4 to negative 2. In fact, I'm going to write it that way. From negative 4 to negative 2. Where's the other interval where it would be negative? So let's keep following the graph. So what answer do we have now for the function? We just said at 2 the answer is 0. Well, from 0, what happens? It increases by what amount? 8. So by the time it's at 6, 0 plus 8, now the value of the function is 8. Then what happens after? Well, it goes negative. But we have a positive value to begin with. So we're starting at positive 8. This continues, and we have a negative 8. Well, this answer is still positive all the way up to 10, because 8 take away 8, the answer is back to 0. So we have positive, and as we are becoming decreasing, it's still a positive answer. So decreasing, decreasing, still decreasing, and it decreases by negative 8. So 8 take away 8, now the answer again is 0. So where is it negative again? Well, after 10, now the answer then goes decreasing by 4. So the answer is negative again after 10. So where's the next interval where it's negative? And the answer is from 10 to 12. And it includes 10 to 12 because 0 is included. So where are the two intervals where the function is negative values? And it's negative 4 to negative 2 and 10 to 12. To me, this would be a question. If this is 2020 and you are doing the exam online, this is the type of question you can expect. One where a calculator, one where taking a picture, photo math, all that wouldn't help you as much. That you actually have to know the concepts of it to be able to support you. So this is a good practice question, I think, for that. And even if it's not 2020, this would be a good practice question for a free response without a calculator. All right, where are we at? That's part D, right? It's over. So let's make sure we write this down, 3D. This is 3C. So 3C, 3D. And you know what? We're done. Mr. D Math, over and out. And until next time.